Okay, so for implicit differentiation, we're going to find dy dx. So that means we're going to differentiate every variable with respect to x. So when I find the derivative of x squared, we just use the normal power rule. But when I find the derivative of y, I need a dy dx along with the normal derivative. And then the derivative of 4 is 0. So now solving for dy dx, I'm going to move the 2x over. And divide by 2y. So y equals negative, dy dx equals negative x over y. Now for number 2, we need the product rule for xy. So I'm going to individually find the derivative of each piece. And then the product rule says x times dy dx plus y times 1. And then I'm going to take the derivative of y squared, the derivative of x, and the derivative of y. Now I want to get all of the dy dx's on one side and everything else on the other. So I'm going to subtract this dy dx to this side. And I'm going to subtract this y to this side. Now that we have all of our terms with dy dx on one side, I'm going to factor out the dy dx. And I'm left with x plus 2y minus 1. And then as a final answer, I'm going to divide both sides by x plus 2y minus 1. So we're going to repeat that process for 3 and 4. And I want to get the dy dx by itself. So I'm going to subtract the 1. And divide by 3y squared. So here I divided by 3y squared. Now for number 4, we need the product rule again. When I take the derivative of x times y, I get this piece. Now I'm going to move everything that's not a dy dx to the left, from the left to the right, so that's negative 2x minus y. And for what's left, I'm going to factor out dy dx. I'm going to divide both sides by x plus 2y. So dy dx equals this quotient. Now finding the derivative of e to the y, that is e to the y dy dx. Then I'm going to bring this negative y down. This is a negative y, so the derivative of negative y times this negative 1, I'm going to get plus dy dx e to the negative y equals 2. So now I'm going to factor out dy dx. And divide by the e's. So as a refresher from first semester, when we had e to the u, the derivative of that was u prime e to the u. So thinking up here about our e to the negative y, the derivative of negative y is negative dy dx. and then e to the negative y. So when I did the negative here times this negative, that's how I got plus. Also, for number 6 from first semester, the derivative of ln of a function u is u prime times 1 over u. So when we go to find the derivative of all these pieces, u prime is dy dx times 1 over y. So when I factor out dy dx, I'm left with 1 plus 1 over y equals 2x. Before I divide this to the other side, I'm going to make it one fraction and get a common denominator. So this 1 is y over y. And now the reason I did that, oops, is now to isolate the dy dx, I can multiply both sides by y over y plus 1. So that cancels with that, and that cancels with that. So my final answer is 2xy over y plus 1. When you multiply fractions, you go across the top and across the bottom. Okay, so again, we need the product rule here. We have x squared and y squared. So here's my original functions, the derivative of each one. So the product rule says x squared, so 2x squared y dy dx plus 2xy squared. Take x squared times this one, y squared times that one, minus 4 dy dx equals 0. Okay, so I'm going to move this term to the left and factor out a dy dx of what's on the right-hand side, and then divide both sides by this term. Now I notice that the top has a 2, and down here on the bottom I can actually factor out a 2 as well. So I'm going to rewrite my numerator. But on the bottom, if I factor out a 2, I can then cancel this 2 with this 2 and reduce my fraction so that I get negative xy squared over x squared y minus 2. Okay, so using the same process, we're going to find the derivative of number 8, but when I do the product rule, I'm going to use negative x and y. So that's negative 1 and dy dx. So the derivative of 4y squared is 8y dy dx, and then negative x dy dx, and negative 1 times y. I'm going to move this y over and factor out a dy dx from these terms, and divide both sides by 8y minus x. Okay, so now for the last two, we have to use the derivative to find the equation of the tangent line. So the equation of the tangent line, we're going to use point-slope form, where this is our x1 and y1, and m we get from dy dx. So first, I need to find dy dx to get my slope. Well, I need the product rule here. Okay, so the derivative of xy squared is x times 2y dy dx plus y squared equals 0. So now I have to isolate dy dx. I'm going to subtract the y squared over and divide by 2xy. Now I could reduce this. I can cancel out a y, or I can just plug in my values here. But I want you to be really careful of this negative y squared. It means negative of negative 2 squared. And here's why that makes a difference. Negative 2 squared is positive 4, but you have to bring down this negative. And then 2 times negative 2 times 4 is negative 16. So I get a slope of 1/4, positive 1/4. So plugging everything into my equation, y minus negative 2 is y plus 2. I'm going to distribute my 1/4 to both the x and the negative 4. Minus 2 to both sides. So my equation of the tangent line is y equals 1/4 x minus 3. Okay, we're going to use the same process for number 10. The derivative of sine is cosine, and we also need the dy dx. So dy dx equals 1 over cosine of y. So plugging in my point, 1 over cosine of 0. Cosine of 0, thinking of our unit circle, is 1. So our slope is 1. So using point slope form again, y minus 0 equals 1 times x minus 0. So the equation of the tangent line is y equals x.